WWT presents Partner Spotlight.
Hello everybody, and welcome to another episode of WWT Presents Partner Spotlight. My name is Brian Felt, and I am thrilled to be joined today by Dr. Eng Lim Goh of HPE. Dr. Goh, thank you so much for taking the time today to join us. If you could, maybe introduce yourself and talk to us a lot about the state of AI and where we're at.
Yeah, thank you, Brian. Thank you for the time, and we are very honored and also appreciate your partnership. You all are a very important part of our HPE partnership program. Now, I'm Senior Vice President of Data and AI at Hewlett-Packard Enterprise, HPE. And AI is now a big topic being discussed quite a bit. And interestingly, my first association with it was back in '96, where Silicon Graphics, now acquired by HPE, we were building these, what they call then data mining solutions. They're using many of the same math and methods that AI, large language models, are using today, neural networks and such like. So the industry is been moving forward tremendously, but the key has always been data. That's why I say my job really is data and AI, not AI and data, right? Data comes first.
Now, you mentioned, I've heard you say before, and it's a wonderfully simple statement, but there's a lot in there, that data is the source of machine learning for or to inform artificial intelligence.
Yes, I always say data, right? So how do you link the three things, the three important things, right? Data, machine learning, artificial intelligence. So the way I put it simply is that data is the source of a machine learning to be artificially intelligent. So it starts all with that data. And in many of our joint customers, right, there is of course in more recently implementing proprietary as well as on-prem large language models to the intelligent edge. I always say you start with the data. Get your data maturity up first, get your data organized, get your data silos federated. Yeah, this is going to be the key first, right, before you start on AI projects. Yeah.
What kind of sense do you get in terms of organizations' data maturity? Are they well ahead of the curve? Are they behind?
Yeah, that's a great question, right? And that's part of the reason why we did a survey of 8,625, in fact I remember the number, decision makers globally. So then we, based on the questionnaires we put out, we classified them from level 1 data maturity to level 5 data maturity. Level 5 would be when all their data silos within the company, many of them marketing, legal, finance, manufacturing, sales, and so on, right? All the data silos are either have a data warehouse integration or data federation integrated. That's step 1. Step 2, at level 5, you not only have to do the internal integration, you must also be integrated with data coming in at the edge, because that's your latest data. That's going to be very important, more and more now, with data growing tremendously, the sensors growing and quantity of sensors growing. The amount of data collected at the edge is going to overwhelm the network. Or you may not want to afford to bring everything back, or even if you did, it wouldn't be back in time. So integration of the edge data, and level 5 will also require you to integrate with your partners. So level 5 is a very, very high requirement where you have to integrate within your silos within the company, with the edge, and with your partners. And then level 1 is nothing is integrated, right? Guess what? After the survey all came back, 8,625 of them, the average was 2.6. Between 1 and level 5, 2.6. It tells us one thing: if you are working with your customers and they are not, their data maturity is not high, not to be too worried. The world is not that advanced, 2.6. But at the same time, you have to be concerned that they now know this, and the world is starting to get their data organized. So you need to start now.
So in one sense, organizations that are at that 2 or 3 or somewhere in between may not feel as bad because most organizations are right there with them. But what implications are there when you are there? What challenges does that bring?
Yeah, in fact, at today's talk at the WWT sales kickoff, a great question. You have very smart people in your company. One of the great questions was, what was therefore the implication? Should you therefore not to be too worried because the world is like you, between 2 and 3? On one hand, yes, But on the other hand, the implication is that the world now knows this, and they're now investing in organizing their data, integrating their data. So you have to start now, right? So on one hand, you're reassured that you're not that far behind, but on the other hand, people are starting and moving quickly. So you have to be there and start investing in data maturity of your organization. And one the big implication of this in AI projects, right, is that if your data is not organized, when you embark on an AI project, you typically have these stages. So you do a POC, then you collect and organize your data, then you decide on your model, you train it, assuming you're doing an on-prem one, and then you go through a stage of deployment and testing and deployment. If your data maturity is low, 90% of your time is spent organizing data. That would mean if your data was organized, and you don't have to spend at 90%, but instead only reduce it to 40%, 30%, you'll be ahead in deploying a solution faster if your data is matured. If data is not mature, you'll be spending a lot of time organizing data before you even start on your AI project.
Now, as organizations do work to advance themselves up to that level 5, or maybe the 5 is always a future phase, and it'll be a moving
3
target.
to 4 would be the goal.
Yeah, as they get to 2 or 3 or 4,
yes.
What role does computing have in all this in terms of accelerating and enabling?
Yeah, again, another great question. Yeah, we had a few use cases where we did quite a bit of learning, right? Let's use one interesting one, right? We have lots of industrial example, but use an example where we work with CMU, Carnegie Mellon University, to supply them with systems to train their poker bot. Yeah, back a few years, they came up with their poker bot, and then went out to compete with the 4 top poker players in a casino. Lost $1 million, virtual money, right? And then Professor Sandholm interviewed, and his team interviewed the 4 top poker players, and found out that all 4 almost said the same thing. The poker bot did not bluff very well. Texas Hold'em, heads up, no limit here. I'm not a poker player, but I remember that term. Did not bluff very well. Why? Because after playing the bot, the top poker players could have sensed the way it bluffed and then outwit it. Getting this feedback, Professor Sandholm went back and said, okay, I'm going to come back next year, the goal. And in that 1 year, I'm going to train the system to just bluff very well, right? But then in order to come back 1 year, he needed a machine 10 times faster. Or else if the machine was 2 times faster, you'll take 5 years. So that was a big lesson. 10 times faster machine in order to train the system on, to fine tune on bluffing. So it come back within a year. Because if it take too long, people lose interest and so on. So it took 2 bots, right? Just play each other, 1 trillion games in 1 year, 10 times faster machine. We supply it with HPE equipment, right? And every time one of the bot beat the other because it used bluffing, right, it was given more credit. So after 1 trillion games, whichever bot that has the biggest credit must be bluffing really well. So deployed it after a year, and now beat the top 4 poker players, top 4 poker players, and asked them again. They said, yeah, it bluffed really well now. It bluffed like no humans. That was the interesting thing, because it was not trained on human plays. It was just 2 bots playing each other, and they have been explored space in poker that humans have not. So it bluffed really well now. So the big lesson, one of the big implications was that compute power can make a difference, right? You need 10 times faster in order to come back in a year. If it was 5 times faster than the older machine, we have to come back in 2 years, right? So in this specific example, you could use compute power to buy time. That was a big lesson.
Yeah, that's very interesting for sure. I want to get back to one thing you did mention, and you were talking about the proliferation of devices and data on the edge. Mm-hmm. So as more and more data gets produced and generated on the edge, maybe even more than half of the world's data at some point, what does that mean for the edge and AI? And I know I've heard you talk a lot about the intelligent edge, so tell us a little bit more about that.
Yeah, so we've been focused a lot on the cloud, and the cloud needs to be hybrid because you have a mix of public cloud data colo, on-prem, and edge, right? So you want capability to span all that seamlessly. But then the edge also is becoming important. The edge used to be data centers that you put in a sports stadium, data centers you put mini servers that you put in a factory to be able to connect to robots, right? But then from these kinds of edge systems, you started to see edge proliferate to aircrafts collecting data, and to even more quantity, drones collecting data, to billions of people carrying cell phone that you want to collect data of, when given permission, right? To all the way to light bulbs. You can buy a $10 light bulb with Wi-Fi and Bluetooth in it. So the quantity is becoming so massive that the amount of data collected or the sensitivity of the data sensors have grown so fast that you cannot either afford to bring everything back to the cloud, or even if you want to afford to bring everything back to the cloud, you can't bring it back in time. There was another statistics that says that 50% of the data for many customers loses value after a few hours. So if you take a few hours to send everything back, the data has already lost value. All these are telling us, right, with the sensor sensitivity going up, growing faster than the bandwidth cost dropping, right? That alone, when you go from 2K to 4K resolution, assuming you want to send the 4K back, the growth has grown 4 times, right? 2K to 4K is because it's square. It goes rectangle, it goes 4 times. But your bandwidth cost reduction is gone linearly, while sensitivity of sensors has grown exponentially if you include their quantity. So quantity of sensors are growing, sensitivity of sensors is growing. And the fact that more and more people are asking for real-time data, right? Data that becomes stale very quickly. All this is telling us, therefore, that there are times where you need to push intelligence to the edge, and have servers out there at the edge, right? To be able to make decisions on the data you collect immediately. But of course, still send everything back to the cloud. But for the immediate answers, you need servers, intelligence at the edge. And not only that, when the data grows so fast, if you don't want to afford to send everything back, you need some intelligence to decide what to send back and what not to. And for those that you're not sending back, you have to decide, do you throw them away or you process them on site, right? So all this requires intelligence at the edge, and therefore we call them intelligent edge. And more and more now, and what it means is compute power at the edge, sometimes ruggedized servers at the edge, and all this means that we put it under the intelligent edge area. And therefore what we're saying is that although our bulk of our business is on the hybrid cloud side today, more and more you start to see for those corporations that want to be competitive with real-time data, because their data goes stale quickly, to be competitive, they want their edge to be intelligent also. And I believe this is going to be a huge next part of our business.
Yeah, I wonder, with that time-sensitive data in mind, maybe give us 1 or 2 use cases or practical instances that we've seen that in action in the real world.
Yeah, from the very fundamental one, right, from the industrial one, right, where people are putting sensors on every piece of machinery out there. Let's say you have 1,000 pieces of rotating machine in a big factory, right? Traditionally, but it's still very advanced, you would collect all that sensors, right, listening devices, and collect all the vibration data back to the cloud. And on the cloud side, you have keep a log of what all these machinery should sound like. So you compare the real-time data with the reference data to compare them, and you can get a sense of whether this machinery is working well, or needs maintenance soon, or about to break. So you preemptively replace them. So these are the preemptive maintenance and preemptive replacement are some of the capability out there with real-time data. But as the amount of things you want to monitor grows, not just hundreds, thousands, tens of thousands, hundreds of thousands, everything you want to sense, right? And these capability, these machinery are starting to demand very, very immediate reaction, these high-frequency devices, than you may not afford to be able to send everything back, especially image data and so on, which takes a lot more to send back. You may want to push some intelligence out there to make those necessarily immediate decisions, while you are also making longer term decisions back at the cloud side. So you're not removing decisions being sent out from the cloud, but you're saying certain ones need to be done at the edge for those immediate, that requires immediate response. And we have seen many of these cases where we're pushing some compute capability out there, servers out there, in order to process them immediately. So we have also another use case of the intelligent edge, right? And this one is the space station, right? So the traditional way is that as the astronauts go out to do spacewalks, the glove they use actually wears out very quickly, right? What they do is they take a camera and do many images of the glove, hundreds and hundreds of images of the glove, and there are many gloves, and then chunk sent all these images. Can take hours because of sometimes network interruption, hours to send all the glove images down to the NASA data center on Earth, and it takes just seconds to do AI imaging and send back the decisions as to what to do with those gloves out. So transmission in hours, processing in seconds, and then the answer comes back. But it takes hours to transmit the data. So what we did is we put a server, intelligent edge server, up there, a straight off-the-shelf HPE server, which is tested can work on the space station. And that server collects all the gloves images, it's sent there first. Now it won't take, like the data center on Earth that would take seconds, it'll take 20 minutes to process the data and then give the answer. So that 20 minutes is still faster than the hours to send the data to Earth. So this is an example where it takes, although it takes slower to process the data at the edge, the total time is still shorter if you include the transmission time to Earth. Now, eventually all the data still gets back to Earth to get these high resolution answers, right? But at least you can get immediate answers while at the edge.
So you're processing data literally above the cloud.
Above the cloud, right. So I'd like to say these servers are above the cloud.
Yeah.
Literally.
Yeah. Well, let's talk about some of the work that the HPE and WWT are doing together, specifically maybe around the AI Proving Ground Lab and the value that provides. So
you have, Fortune 500 companies. We have them together with WWT. So this is a great partnership, right? Together we can approach a top Fortune 500 companies, right, and have the credibility to help them deploy solutions. Many of these big Fortune 500 companies, especially in finance, for example, where highly regulated, right, would already have hired, given the AI emergence and realization, we already have hired data scientists, machine learning engineers to do POCs. Very likely with sanitized data on the public cloud. The POC is done. And typically after they've done the POCs, they already have an idea of, for example, what large language models they want to use based on proprietary ones, right? And certain ones where, because the data is highly sensitive, regulated, or because they want consistent answers, do the fine-tuning for behavior themselves on the large language model. Those chunks, they want to do their own customized large language models on-prem, right? So some chunk with proprietary, some chunk on-prem. But then they also want to be able to have a single layer to be able to access public cloud, on-prem, and all the different solutions all seamlessly. And this is where our partnership comes in, right? The customer wants a solution. We have pieces, since 2015, we've did 26 acquisitions to be able to come up with this integration layer called HPE GreenLake, right? To have all the pieces in place. But then a Fortune 500 company already have a clear idea, at least on the solution side, what they want. We need to come in as a partnership, right? To come in below to build the solution, to build the infrastructure below to meet those solution needs. And that includes building the HPC system in some cases, many cases, right? I'll elaborate that later. An AI native HPC system as opposed to a cloud native HPC system. I'll tell you the difference later. Plus all the different pieces of solutions, right? And together with WWT, integrate it seamlessly with HPE GreenLake and deliver it to meet the solution requirements of this Fortune 500. Because Fortune 500 companies are solution focused. They've done all the POC focus in that. But at the infrastructure layer, at the solution pieces that come in to build the solution, plus the integration layer, they want to leave it to somebody else. Yeah. They just want to have access to that seamless layer, integrated layer. And this is where our partnership have come in. And a big part of our partnership is building these, what I call HPC systems that are AI native. Very different from a cloud native system where many of these internet companies are specialized in building. How are they different? A cloud native system is like you have many, many workloads like search, running Outlook 365, many, many workloads servicing many, many customers sitting on many nodes. That's a cloud native. See? Many workloads on many nodes, right? Cloud native. And AI native, like a large language model, would have one workload across many nodes. So that's the difference. Many workload on many nodes, cloud native. AI native is one workload on many nodes. And because of this, we've customized configured our solutions to be much more energy efficient, because we keep that one workload on many nodes in mind, and therefore we build our systems with bigger chunks, and that allows us to be more energy efficient, for example. So that also works into the ESG part of our customers.
Last question for you, but many of our clients or many of our viewers watching today, they're at various stages of their AI journey, and maybe they're looking to understand more about what AI is and what it can do for them, or maybe they're on a more mature conversation. But from your vantage, what are maybe some of the one or two things that you would tell them to prioritize to get the ball rolling?
So for larger customers, right, typically Fortune 500, the top end of those, they already have a clear idea what they need, because they've done their POCs, they know what solutions they want, and we come in to build out the solutions for what they need. For smaller companies, many of them are just starting out on their journey, and this is where we have a consulting group to come in and help identify low-hanging fruits, usually, to prove to their board that this can work before we move on to bigger projects, right? And usually we start smaller, but they can prove capability sooner. Right? Don't try to do too big a project, right? And also not to help to build up your team. So I'm not saying that they're just two different customers, right? You have a spectrum, but these are the both ends of it. But regardless of where they are, I always fasten, whether you're big or small, advanced or starting out, to focus on your data. It is the data maturity that you need to work on first, right? You may not need to get your entire organization data matured, organized and integrated, but you start organizing your data. And that is first thing, the key word is integrating it, so that whatever AI applications you build, you don't have to, case by case, try to extract data from all your different silos at the edge in order to build a case by case AI solution. Start organizing your data, even if you don't have in mind an AI solution you want to build. Start organizing the data, because eventually, either way, even if you don't build an AI solution, a data matured organization tend to be more efficient, right? Many startup companies, right? Traditional companies start with silos. I mean, those that are 3 decades old, they start with silos. They advance to federating it. But many internet companies start out knowing that data maturity is at the forefront. That's why many of these startup internet-based companies are essentially data companies, right? So I always ask them, whether you are advanced or you're just starting out, focus on organizing your data first, because it is the data that is the source of machine learning to be artificially intelligent. It starts with the data.
Well, Dr. Goh, thank you so much for your time here today. I very much appreciate it. We could talk about this for hours, but it was great insight, great context. Thank you to all of our viewers out there as well. If you'd like, you can check out more information, more great content on WWT.com. You can head over to the HPE partner page. And I know, Dr. Goh, you have a lot of good content out there as well on HPE.com and on YouTube. So any of those 3 sources would be great.
Thank you.